Hello everyone and welcome to our universe. Today we'll be talking about the origins of gravity. So you might be thinking to yourself, well, gravity is always studied, physicists always think about it, and it's something that pretty much encapsulates all of us on the planet Earth. It also seems to dominate our whole universe, with things like keeping the planets in position, keeping the moons around the planet, keeping all the stars together, and also our sun orbiting the Milky Way galaxy. There are also a lot more other things that gravity does that affects our everyday lives and the universe around us. But because of gravity, we don't just simply float off into space when we jump into the air, or objects simply just don't fall from the sky, unless they really want to. But it's great just understanding gravity, but where exactly does gravity come from? How do we really know about the origins of gravity? How does it start? And how strong can it really get? And how does it really work? So we are seemingly bound to the Earth's surface. This is due to an invisible force that we call gravity. To physicists, gravity is one of the most mysterious and unsolved things in the universe, because we just don't have a true understanding of how it really works. Isaac Newton was pretty much a pioneer in understanding gravity. He created the laws of gravitation. He basically said that any two objects in the universe exert a force of attraction on each other, and this is due to the relationship on the mass of the two objects and the distance between them. The greater the mass of the two objects and the shorter of the distance between them, they will exert a stronger gravitational force on each other. And this can be multiplied to have several objects, so it can get very complex very quickly. A great example of this is our solar system. Not only do you have the sun, the moon and the earth exerting gravity on each other, but you also have all the other planets, the moons, the comets, the asteroids, and all the other garbage that makes up the solar system. And this means that all these objects have an attraction to every other object, assuming that they all have mass. And these gravitational effects can change due to the distance and the mass of the object. So then someone called Albert Einstein came along with his theory of relativity. He explained how gravity is more than just a force. It's kind of a curvature in the fabric of what we call space-time, where space and time are actually combined into one entity. This was an ingenious idea by Albert Einstein. The mass of an object can cause the space around it to bend and warp depending on its mass. A great example of this is using a rubber sheet and sitting a heavy ball in the center. This heavy ball will warp the rubber sheet. If we introduce smaller and lighter balls around the heavier one, we will see that they fall towards the heavier object because of the heavier ball's mass. But in reality, we can't see the curvature of space directly. We can only see it indirectly by the motions of the objects. This means that any object that gets too close to another heavier object will be affected because the space that it is moving through is curved towards the heavier object. Another thing that astronomers look out for is a phenomenon called gravitational lensing. This is basically when gravity has an effect on light. A great example of this is a large galaxy or a cluster of galaxies. This can cause a straight beam of light to curve around these large objects, creating a lensed effect. But looking at them even closer, you can see that the light actually curves. But the most strangest thing about gravity is it's the weakest of the four fundamental forces. Out of electromagnet, the strong nuclear force, and the weak nuclear force, the gravitational force is the weakest at the quantum level. There are also theories that state that gravity could also be a particle. Some scientists have proposed that particles called gravitons cause objects to be attracted to one another. This is just simply a theory though, but it would explain why gravity is so weak at such a smaller level. Also, it could be a great idea into understanding new phenomena within our universe that don't quite match our understanding of gravity. A great example of this is the center of black holes. Another idea that is vastly more popular and pretty much exists within our universe are gravitational waves. These are generated when an object is accelerated by an external force. In the last couple of years, we've had some great observations of gravitational waves, and hopefully within the future we'll know a lot more about them, and hopefully learn a lot more about how gravity really works. So our overall conclusion to gravity is that it works, but only when it's convenient to our mathematics. When you look at certain places in the universe, gravity simply breaks down. And this is very obvious when you look at the very small bits of the universe and the very large bits of the universe. These are the levels of atoms and molecules where gravity just stops working, and the very big side of the universe, where we try to explain how galaxies keep themselves together and how the universe expands. There's something else out there that is stopping us from understanding gravity completely. Like I said before, black holes and the moment of the Big Bang do not work with our current understanding of our mathematics of how gravity works. The problem is with physics is it seems to be in two parts, the astrophysics side and the particle physics side, and we can't quite fit them together to create something that is an overall structure of what the universe really is. But scientists are really coming up with some great ideas, trying to put the fundamental forces into one to create one gigantic ultimate force of the universe. To be honest, that sounds rather familiar to a force that we all know and love. Our current understanding of the universe allows us to build upon of what we already know. Like I said before, we know what's wrong with the universe, but we don't know how to figure it out. But there are some great theories, some great experiments, and some great minds really trying to tackle the problem of the origin of gravity. So I hope that's given you a great insight into the origin of gravity, and why it doesn't seem to work at either extremes of the universe. Also, if you want to know any more about how gravity works, the laws of gravitation, and also a little bit about how they're trying to figure out more about gravity, I'll put some links in the description below. And as always, if you've enjoyed the video, click the like button, and if you want to support the channel, click subscribe and support our Patreon page. Thank you for watching, and thank you for your support.